All right, so my name is Jacob Labrie, and I am doing my presentation on the hormonal control of implantation in early embryonic development. So I wanted to start off with the slide focusing on hormones because that's kind of the basis of the presentation. And not only that, but we have a picture here that I actually took out from our textbook, and it does a really, really good job with kind of a basic look at how hormones, where they come from and what they act on, and yeah, their target cells. So we have three that I really want to focus on when it comes to the reproductive system. So we have gonadotropin releasing hormone, which actually sits here in the hypothalamus. As you can see, this will come down into the anterior pituitary, which will then act there to release both the luteinizing hormone and the follicle stimulating hormone. And this has a really good picture of what these hormones do and where they act on. So you can see that we have FSH that goes to gamete production in the gonads, either the testes or the ovaries. And then we have luteinizing hormone, which goes to endocrine cells for steroids and peptide hormones, but in females also goes to gamete production. When luteinizing hormone and follicle stimulating hormone act on these endocrine cells that release the steroids, this will create a long loop feedback, which may be negative or positive in nature. So you can see that there's stimulation from the central nervous system down to the hypothalamus, which goes to the anterior pituitary and then goes throughout the body. So I wanted to start focusing with the male portion of it. So that is spermatogenesis. So like I just brought up, gonadotropin releasing hormone, FSH, LH. So these have both a target. The FSH and LH have both a target in the female and male, but so we'll focus on the males first. So as you can see, when it's released, FSH goes through a second messenger system, and it does in the end end up having androgen binding protein, which will also work with testosterone. And what this does is it will mature sperm cells and cause them to, after I think it was about 12 or so days, the sperm cells will be mature after going through the epididymis. So you can see their spermatogonium, spermatocytes, and then you can see here the sperm with the flagellum, which allows them to move. We will go into that a little bit later after I discuss the female reproduction system. But you can see how FSH and LH work here. LH in males will also go to the Leydig cells to release testosterone, which will work on secondary sex characteristics in males. It could be, body hair, facial hair, that kinds of stuff for secondary characteristics. And now we're going to look at the hormonal control of the menstrual cycle. So we already know where, I just had two pictures of, hypothalamus release of the gonadotropin releasing factor, which will go down the pituitary, release the two hormones that we've been really focusing on, which are FSH and LH. So in females, it's both also a release of follicle stimulating hormone and luteinizing hormone, but it goes through a cycle. So for men, I forgot to say, but men make about 200 million sperm cells every day, which is a lot. But after ejaculation, that's pretty much the amount of sperm that is actually released. So in the grand scheme of things, it's not a lot. But then you look at the menstrual cycle. I apologize for it being blurry. I had to blow it up a little bit so you could see. The menstrual cycle is about from 0 to 28 days, so it's about a month. So when it comes to female reproduction, that's kind of their cycle, is a month instead of a day like in men. So you can see here in the beginning, when menstruation starts from day 0 to 4, you can see pretty stable levels of FSH, LH, and progesterone is pretty low. But when it goes through the ovulation phase, there will be an increase in both FSH and LH, mainly luteinizing hormone. It goes through this process called LH surge, which is when the follicle has a mature oocyte that is then expelled from the follicle. and will go into the, from the ovaries, will be expelled into the fallopian tubes. So you can see the surge of LH, which leads to the release of the oocyte. And then you can kind of see right after day 14, 15, that they start to drop. And then progesterone just starts to begin and go increase. So this is when the oocyte, after it's been expelled, the rest of the follicle will turn into the corpora lutea. Yeah, and will eventually kind of just shrivel off and end, where then when it ends, we'll redo the cycle. So that's with the stimulation of progesterone, with the increase of progesterone. So to kind of tie it all together when it comes to male and female hormonal control, so we know the hormones behind it now, but I really wanted to go over and review what happens in relation to these. So we see here, this is the ovary, and this is the fallopian tube that goes down into the uterus. So we have the ovary here, where the oocyte was expelled, right here, and that was during ovulation. So now we have the oocyte, which has this barrier, I guess I should say, around it, which needs to be penetrated by the sperm. So we all know how, the birds and the bees, and how sperm gets into the uterus, and then it will travel down the fallopian tube, where it will penetrate this zone here that the oocyte has. It's actually the acrosomal head is what releases these digestive enzymes, which penetrate the oocyte. Once penetrated, it will then be fertilized. So then once fertilized, there will be this formation, I guess it says a pronuclei, but really this is when it starts the division. So they're starting to be the division, and from day 1 to day 4, there's multiple divisions until it leads to a morula is around day 4. So that's about a 16 cell state. It doesn't really show it here, but that's what a morula is. And then it will go, and around day 5 will become a blastocyst. And then the blastocyst will shed this lining that it has so it can attach to the endometrium. And then, months and months later, the formation of a fetus into a baby, to when it is, then released. So looking at a concept map here, I wanted to kind of bring everything together. It's the best one I could find that really shows LH and FSH's release from the anterior pituitary, both on the testes and the ovary. So again, they're both released for both males and females, and both act in order, spermatogenesis, or then the menstrual cycle for ovulation into the oocyte. So they do have different effects per sex, but all in all, they do. These two hormones are the hormones that are used to control the cycle. If there was no FSH or there was no LH in either male or female, let's say that there was, something wrong with the hormonal release, or the anterior pituitary did not form correctly in order to release these, or doesn't create these in some way, somehow these weren't being released. This would actually lead to an individual being sterile. So there would be no spermatogenesis, there would be no production of sperm for males, or if there was, it most likely would not be considered normal, and could potentially not be able to penetrate the oocyte or some way, or give, lead to fertilization. And then the ovary here, if there was no FSH or LH, this most likely wouldn't lead to the LH surge in ovulation, which would release the oocyte. So most likely there just would not be an oocyte released from the ovaries into the fallopian tubes. Therefore, the fertilization could not happen, because the sperm would not have an egg in order to inseminate and fertilize, and therefore there would be no pregnancy. So this concludes my presentation on the hormonal controls of implantation, which we went over very briefly, in early embryonic development.